Okay, welcome to another Ginger Mathematician video where I'm going to go through IGCSE questions here on circle theorems. This has been requested, so many people have been asking for this kind of video. So I'm going to spend about an hour here going through typical circle theorems questions, some short answer questions, some long answer questions. So by the end of this video, you will feel confident for your exams. Right, let's get started. So we have a short answer question to start with. First of all, so question 9. So A, B, C and D are points on the circle and we're given the angle BOD, which is equal to 130 degrees. Now remember how the angle is named. You take the middle letter here, O, and that tells you where the angle is. So B to O to D. So that gives you the information of what the angle is. And we want to find, first of all, the angle DCB. Now, because the C is in the middle, we know the angle is by C, and then we use the letters to identify it. So D to C to B, that's going to be this angle here. And the first thing I notice with this kind of question, first of all, it's a 1 mark question, so it shouldn't be anything too big in terms of calculation, is that if I actually extend from C all the way along until I hit the 2 vertices, notice that if I do extend this angle all the way along, then I do hit the vertices D and B. Now they actually share with another angle that we already know. So if I get my pen out, there we are, pen's not being very cooperative. There we are. So if I go to this vertex D and vertex B, notice I can also draw a line from here, and that goes to the center. So whenever I'm doing a question like this, I'm always looking for, okay, is this angle related in some way by looking at the vertex it ends up at to another angle? And it is. It's related to the 130 degrees. And one of the circle theorem rules that you need to know is that the angle at the center is always twice the angle at the circumference when in the same segment. And the thing I've just shown you here is showing that they're in the same segment. So in order to work out this angle, now of course this is not to scale, it does say this here, but at least this gives you an idea of what kind of size it is. It's obviously smaller than 130 degrees, but to work out this angle, we just take the 130 and then divide it by 2. If we do that, that's going to be equal to 65 degrees. So it's going to be a circle theorem we're going to see lots during this video, so try and be aware of it as well. And now we want to find angle BAD. Again, 1 mark, so it shouldn't be a big calculation. We've got angle BAD, so again we're looking for that middle letter, which is A, so you know it's up here, and then you've got BAD, so we're looking for this angle here. And the biggest mistake people make here is incorrectly using the idea of a cyclic quadrilateral, or cyclic quad, as I like to call it. And this rule says that opposite angles of a cyclic quad add up to 180 degrees. However, this four-sided shape we have here is not a cyclic quad. And the reason for that is that one of the vertices is not on the circumference, it's actually on the center instead. So what I like to do in this kind of situation is actually draw a separate shape in. So I'm going to draw a dotted line. This is not the only way you can approach this question, but I think this is a nice representation of why this works. So if I draw a dotted line in and then mark in this angle, notice we can use the same rule that we did for here, for 65 degrees, for also this angle, because they're on the same segment. So this is equal to 65 degrees. This almost identical rule to this one over here. Now at this point, if I now draw around the shape, so I'm going to do this in green just so you can see the sort of kite sort of shape that I've drawn here, notice that this is a cyclic quadrilateral because all 4 vertices lie on the circumference, lie on the edge of the circle. So now I can use that rule where this angle and this angle add up to 180 degrees. So you want to be very careful using cyclic quads. You need to make sure every vertex is on the circumference. So if these two add up to 180, then all I need to do here is 180 minus 65, and that will be equal to 115 degrees. So I can pop that in. And if you're ever unsure about the cyclic quad questions, always check, are every single vertex on the circumference? That is really, really important. And if it isn't, you can do this nice little trick here, where you can actually draw a shape with all the vertices on the circumference instead. So you can see the answers there, and you can see there's a follow through mark if you got A incorrect. They use this angle over here, but I just drew in a separate shape to work that out. Right, and now on to a more extended question. So this is question 12, and A, B, C, D lie in a circle like we've shown. A, D, E and B, C, E are straight lines that intersect at E. So this line and this line intersect at E. BD is equal to DE, so I'm going to put that in straight away. Now I use these two lines here to indicate that they're the same length. So as I'm going to see the information here, I just tick it off. Angle BAD, angle bad, is equal to 4x. So again, that letter there tells us where it is, BAD. So let's pop that in, that's equal to 4x. This is one of the questions where you do have to put the angle in yourself. BCD is equal to 6x, so C is the middle letter. So BCD, that one here, that's equal to 6x. Notice I haven't even looked at the question yet. I'm just putting in the information that I need and then work from there. So BDC, and that's equal to 3x. Okie doke. Perfect. And first of all, we need to find x. So again, one of the first things I'm going to look for, well, usually the first thing I look for is isosceles triangles, but notice we don't have a center of the circle. So the second thing I would look at would be the cyclic quads that I mentioned before. And notice this here that I'm drawing in black, let me just draw this all the way around, is a cyclic quad because it follows that rule that all the vertices, so A, B, and C and D, are all on the circumference. So I can now use that rule of this angle plus this angle equals 180 to good effect. So we have 6x plus 4x is equal to 180 degrees. At this point, this is a straightforward equation to solve here. So 6x plus 4x, that's equal to 10x. So 180. And then what's the opposite of timesing by 10? Well, yeah, we want to divide by 10. Now, many of you can do this mentally, I am aware. Let's cross that out, and then we get x equal to, well, 180 divided by 10, this is equal to 18. So we're going to pop in 18 like so. And now we need to work out the angle CBD. Okay, so let's mark in that angle. Let's use a different color. Put this in green. So CBD, that's this angle here. And now I know what x is, so that's very, very useful. I think the most straightforward way here is that angles in a triangle add up to 180 degrees. So what I'm saying here is that 6x plus 3x, because I know this angle here, plus the angle CBD is equal to 180 degrees. At this point, I know what x is, so I can substitute this in. So we just need to work out what 18 times 3 is, which is 54. 18 times 6. Again, you can use your calculator to do this as well. So that's going to be equal to 108. Okay, so if we add those together, let's just save a bit of time here. So that gives us 162. So we get 162, that's these two things together, plus CBD. Notice I'm showing my working very clearly here for the examiner. And then to work out CBD on its own, what's the opposite of adding 162? Well, we're going to minus 162 from both sides. It looks like we're going to get the same answer of 18 here. So CBD is equal to 18. So let's pop that in here. Okay, so that's equal to 18. So let's just write that in. That could be useful. And the last part of the question, we need to work out angle CDE. Okay, so CDE, that's going to be this angle up here that we're looking for. And right, so I'm going to remove the red 6x, 3x, and 4x and just put in the answers that we know already. So let's just pop that in. So 6x, that was equal to 108. And this one here is equal to 50. Oh, jetzt nicht. 54 degrees. Right, and we want to work out this angle. I think the most straightforward way is we can use angles on a straight line. Equal 180. So this would be equal to 72 degrees. we have an isosceles triangle here. This is why I drew in those lines right at the start of the question. So that means then that this angle also has to be 18. My understanding, and then I can use angles in a triangle on the smaller triangle here. So now, once I've worked out 72 and 18, let's do this in gold. So now I'm going to focus purely on this triangle. So notice once we've got to this question, this actually is not really a circle theorem question anymore. This is just using standard angle facts. So we know all these angles add up to 180. So we do 72 plus 18 plus angle CDE is equal to 180, and this here is equal to 90. Okay, so CDE must also equal 90 as well. Now notice this is a not to scale question. That's important. So on the surface that doesn't look like 90 degrees, but then you can't believe what the diagram always tells you as well. You should put in the degree sign, of course, for the angles too. So just be careful, be very wary of these not to scale questions. You can't believe what you see. Now generally, if it's an acute angle or obtuse angle, that's kind of straightforward and made clear to you, but just don't be fooled by the diagram. That's a really important thing to remember. Right, you can have a look at the answers and you can see where you pick up the method marks. That was 7 marks, considering that probably took about 5-6 minutes. That's pretty good going in terms of time. Right, and now we're going to move on to a slightly different style of question. And one thing they do like to do is mix up a couple of extra topics within circle theorems, and this is a good example here of similarity. So even though this is a video on circle theorems, be aware things like similarity, trigonometry, as you'll see a bit later on, also can emerge as well. So again, I'm not just testing you on circle theorems directly, but for the more difficult questions, there is going to be some crossover. So A, B, C, D lie on the circle, and we've got 2 chords, AC, that length there, and DB, and they intersect at point X, and we need to show the 2 triangles ADX. So let's do a bit of color coding here. So ADX, which is this triangle, and they look similar as well. So again, it makes sense that they would argue this. So this triangle here, and let's do this in different color. BCX, so the other triangle here, are similar. So when they ask you that 2 triangles are similar, you need to show that all the angles are the same. So let's translate that into normal language. So you need to show that all angles are the same. Now some are easier to show than others. Let's start first of all with the angles here. So this angle here and this angle here. Well, these are what called vertically opposite angles, and vertically opposite angles are the same. So AXD is equal to BXC, and that's because vertically opposite angles are equal. So that's the easiest one to show. Angles. Now it's worth writing are equal as well, because there are plenty of rules that that's not true. Think about what we looked at cyclic quads. So writing are equal is important as well. So that's the first angle done. Let's have a look at the other 2 angles, which work in a very, very similar way. So if we look at this angle and this angle, it's the same trick that I showed you before. So imagine we extend this angle all the way along until we hit the vertices. So AB in this case, and then we go along the new line here and the new line here, and notice we get back to C. So these angles are what we call in the same segment. So that's what we're going to write down here. So let's do this in the same color. So again, just have to label the angles correctly here. So ADX is equal to BCX. Angles in same segment are equal. A lot of writing in this question. Feels like a science exam really, doesn't it? Same segment are equal. And in fact, we can do exactly the same process for the angle at the bottom. So put this in yellow. So this angle and this angle, you can do the same process I just did up here. So if you extend them, you get to DC, and then you can come along here to go to B. So this works in exactly the same way. In fact, I'll just copy out what I did before. In this case, we just have to label the angles correctly. So DAX is equal to CBX. And it's for the same reason as above, so angles in the same segment are equal. Please do write this in the exam, don't write as above or something. You want to make sure the examiner is on your side. And in order to make that happen, make sure that you are writing things really clearly, so have no excuse not to give you all 2 marks on that question. Now, as soon as we establish they are similar, they're in the same proportion, and that's going to be important for the next question we see. So now we're told some lengths. So AX is 5 centimeters, so let's pop some of this in. So this is 5 centimeters. DX is 2 centimeters, this is 2. And what's the last one? CX is 3. Okay, that's important. Okay, and now we need to find out a random side probably. BX, yeah, there we are. There's our random side. So we want to find this side. Notice because they're similar, they're in the same proportion, and more specifically, if we get the highlighter out here, this side down here is the same as this side on this triangle. And if you rotate it in your mind, you can even draw it out separately, you'll see that these 2 sides are essentially the same for each triangle. So what we want to work out here is a scale factor. So the way we're going to work out our scale factor, let me get my pen out again, is we're going to use these 2 numbers. So the way we find out a scale factor is take the big number and then divide by the small number. I tend to do it this way around, and that gives me 1.5. So that's a key number that I need, and you have to take corresponding sides. The reason I did it that way around is I'm looking for the larger side here. So in order to work out BX, I take the AX side and times it by the scale factor. So to work out BX, we just take AX and then times it by 1.5, that's scale factor. So that's just 5 times 1.5, and that's going to be our answer of 7.5 centimeters. Again, with a 2-mark question, expecting some calculation, but it shouldn't be overly on the tricky side either. Now, I did warn you about questions like part C. So AD is equal to 4.61, so let's pop that into our diagram. So this side here is 4.61 centimeters. Assume we're going to look for an angle here. Yeah, we're going to look for angle AXD. Aha, this one here. Okay, so we're looking for this angle here. And what I'm going to do actually is I'm going to draw a separate sketch so you can see a bit more clearly what's going on here. So if I draw a sketch of a triangle, again, not to scale by any means. So I'm just drawing out this triangle here. So AXD. Perfect, and we're looking for this angle, so our question mark, and we've got 3 sides, so 2 centimeters, this is now given to us as 4.61 centimeters, and this is 5 centimeters. And one of the things that students do find tricky on, say, a circle theorem question, I'll put that in the category, is realizing when to actually use other areas of mathematics. And as soon as I see this, I see 3 sides, and I'm looking for a missing angle. And as soon as I hear that in my mind, I'm thinking the cosine rule. Yeah, we haven't talked about trig really at all in this video so far, but this cosine rule applies when you have 3 sides and you want to find an angle. And if you've watched my IGCSE trigonometry video, so again, you can feel free to check that out. You'll see that's been recently published in my All Of series, my playlist. I actually recommended to learn this formula off by heart rather than having to rearrange it in the exam. And the formula is the follows. So cos C is equal to a squared plus b squared minus c squared, all divided by 2ab. I do recommend that you learn this off by heart for a situation exactly like this, which is quite a lot of marks as well. Now, the question is, what do these a, b, and c represent, which is a very fair question. So let me just label up this, the sides and angles. The angle we're looking for is going to be my big C. The side opposite that angle is going to be small c, so always have to be related. And then the other 2 sides, doesn't matter which way round we label them, are going to be our A and B. And once I know that, then I can just put this straight into the formula. So the cosine of the angle we're looking for, so AXD, is equal to a squared plus b squared, so 2 squared plus 5 squared minus 4.61 squared divided by 2 lots of AB, so 2 times 2 times 5. But of course we're looking for the actual angle here, we're not looking for the cosine of it, so AXD. And you could write this working, I'm just going to write down directly, if you're happy with this from what we did on trigonometry. Good video to check out, by the way. Again, an hour, I go through everything you need trigonometry-wise to succeed in your IGCSE exam. So you've got 2 times 2 times 5. So very rarely for a circle theorem question, I'm going to go over to my calculator and work this out. Okay, so we want to go to our normal calculating view. Make sure this says deg at the top here. So we're going to go inverse cos. It's doing its crazy thing. Stop doing its crazy thing. It's probably because I'm using the tablet as well. There we are. So I'll just have to put up with the clicks, I'm afraid. So let's just remind ourselves what it is. 2 squared plus 5 squared minus 4.61 squared. 2 squared plus 5 squared minus 4.61 squared divided by 2 times 2 times 5, and then put it all into the calculator, and then we get our answer of 67.207. So 60.207 ... I'm just showing the examiner I've worked this out on my calculator, and then I can round correctly here. So my answer is going to be 67.2 degrees, and that's going to be to 3 significant figures, like so. Right, so you can have a look through the mark scheme and where you pick up the marks. Notice that here I've just gone inverse cos equals that. Again, that picks up the 2 method marks there, and then you get the final answer there too. Okay, notice you only get the marks of 67.2 if you do provide the necessary working for it. So this is what this NFWW means on the mark scheme. Okay, let's continue. So we're on to question 9. This is one of the short answer questions that you get. So A, B, C, D, and E line a circle. Angle BCE is equal to 75. Already marked in our diagram. And find the value of P and the value of Q. Okay, so first of all, we don't have the center of a circle, so no isosceles triangles. So my next thing to look at is the same segments. So if I take this angle here, 75, and go along the 2 sides until I reach a vertex, you'll notice I reach E and B over here. So let me just draw this in. Love these questions. You can just do lots of drawing, basically. Not quite like a geography exam. And then once we've found these 2 vertices, E and B, then we can just go along the edges that are available. So we go along here and along here. So we stay on the same segment, and notice that we actually get to angle P. So by doing this process, we can show actually P is equal to this angle here. So P is equal to 75 degrees. Perfect. And once we've realized that this is 75 degrees, we can use that other rule that I've talked about a lot already, good old cyclic quads, making sure that each of the vertices of our 4-sided shape are on the circumference. And let's just check this. So if I draw around this shape, it is worth repeating these ideas because, as you can see, these circle theorem questions, they come up a lot. Notice each vertex is on the circumference, so everything is good. And remember, the angle here, 75 plus Q equal 180. So Q is equal to 180 minus 75, which is equal to 115 degrees. So we can pop that in for our second mark. Right? Helps if I can actually do oh dear, of course that is equal to 105. That would be very, very true. So when you're in exam, make sure you can actually do some subtracting. Again, I think this is a non-calculator paper, if I remember rightly, from 0607. But this is, of course, equal to 105 degrees. Again, good rule for you at home. Please don't celebrate until you've got the answer and you've got it absolutely correct. Right, those are the answers for you. And let's move on. So now we're on to question 12. So A, B, C, D, and E are points on the circle. Angle CAD good old computer-aided design, is equal to 35 degrees. Yep, that's marked in already. And angle EBD is equal to 15 degrees, which is already marked in as well. And now we need to find the following angles, CBD and CDE. So CBD, got B in the middle, CBD, so that's this angle here. And the way we find this is the same way that we've done the previous question. So first of all, I'm going to look at this. Again, no center of the circle again. We go along the edges until we hit a vertex, which in this case is going to be CD. And then we go along the lines from there until we hit an angle of some kind, which happens to be the one we're exactly looking for. So from this, we know then that this angle 35 is the same as this angle here, which is very, very useful. So let's pop that in. That's equal to 35 degrees. Once we've got that, then we need to look for angle CDE. This is where we have to be careful with which angle we're looking for here. Now we know it's a D, but there's a few angles it could be. So that's why we need to be careful. So C to D to E, that's going to be this entire angle here. So this entire angle, the red angle, the obtuse angle, I've just highlighted. And again, this is very similar to the previous question here. Again, we've got a cyclic quad. There's a little twist on this question compared to what we looked at before. Again, I'm going to draw in the cyclic quad so you can see what's going on. But notice we actually want the combined angle here and here together. So if I draw this out slightly separately, just so you can see a little bit more clearly exactly what's going on, we're focusing on this shape where this angle together is equal to 50 degrees. And we're looking for the angle opposite. Okay, so once you've drawn it out like this, it becomes much more clear that this is going to be a cyclic quad, and then we just do our usual process. So the angle CDE is equal to 180 minus the angle opposite, which is 50, and then that gives us 130, which I did take away correctly this time. Again, which is 130. Another short answer question. So again, you can check the mark scheme. Again, this comes from a 2017 paper on the 0607 course. All right, let's go on to a much more in-depth question. So this is your typical paper 4 question, whichever course that you're doing. And A, B, C, D lie on a circle, center 0. AP and BP are tangents to the circle. That's important. So AP and BP are tangents to the circle. And angle APB, this angle over here, is equal to 46. Now complete the statement. Angle OAP, so OAP, remember middle letter tells us where it is. So this entire angle here is equal to 90 degrees, and the reason for that is because this tangent AP always meets a radius or diameter actually at 90 degrees. So you ever see a tangent and a radius, the first thing that needs to come to mind is a meet at 90. So angle OAP is 90 because tangent and radius meet at 90 degrees. And this is quite a common question they get you to answer as well. Okay, so key words here are tangent and radius. Make sure you mention that. Now this question from here, we have to work out lots of different angles. So we've got B, I, and 2 here on the other page. You can see part 3, part 4, and then we've got part C after that as well. And one of the strategies I like to use here is just work out as many angles as you can, and then let's see afterwards if it actually fits. And this is a strategy I like to use, particularly on these extended questions, these paper 4 questions, where there's a lot of steps involved, and one of the easiest ways of working it out is just by working out all the angles. The first thing to realise is that it's symmetrical here essentially, so it means that this angle is also a right angle. And that's for exactly the same reason as what we did at the top here. And if I actually finish drawing this out, this is again another quadrilateral. It's what we call a so-called tangent kite. I don't know if your teacher has mentioned that phrase, a tangent kite. What this means essentially, and then you can work it out from angles in a quadrilateral add to 360, is that this angle and this angle add up to 180. So if I know that, then if I do 180 minus 46, that's going to give me 134. Double check here, I'm doing that correctly there, of course. So this equal to 134 degrees, because these two opposites are equal to 180. Once I know that, I can use the fact I did right at the start of this video, which is the angle at the center is twice the angle at the circumference on the same arc. So notice if I take this angle and keep it going, I get two vertices A and B, and this is on the same arc as here. So that means that this angle here is going to be half of this angle here. So if I do 134 and then divide it by 2, you can use the bus stop, whatever you want to use here, you're going to get to the answer of 67. So this angle here is equal to 67 degrees. I think we can work out this angle here because we have a cyclic quadrilateral. This is where color coding really does come in handy. So let's do this in gold this time. So notice if I take this shape, so I'm just focusing on this shape here in gold, this is a four-sided shape with all the vertices on the circumference, which means if I take, let's do this in red, this angle and this angle, these need to add up to 180. So then we get 180 minus 67, and that's going to be equal to 113 degrees. Yep, I'm happy with that. Double checking everything. So that's equal to 113 degrees. Is there anything else I'd like to work out here? I could work out these small angles here. So this angle and this angle here. Because notice these are both radiuses, OB and OA. This is an A at the top here. So this is the same length as this length. So I can work out this using isosceles triangles. So the way I do that is do 180 minus 134. That's going to be equal to 46. And then to work out one of these angles, we just then do 46 divided by 2, which is equal to 23. So this angle here is 23 degrees. This angle here is also 23 degrees as well. Is there any other angle that comes to mind to work out? Probably, if I thought about it, I'd probably work out this angle as well. But I'm going to leave it like that for the time being and see how much I've worked out. So, angle AOB. Yes, I've worked out angle AOB. That's 134 degrees. Angle OAB. That's the 23 angle. Yep, so we'll put 23 degrees. Such a satisfying feeling when you've worked out all these different angles and you find basically all these angles are the ones you needed to work out. So we've got that perfect. Angle ACB. That's 67, so we've done that one. Perfect. Angle ADB. Yep, we've worked that one out. That's 113. What a great feeling that is. So notice just by working out all the angles I could, I got 2, 4, 6, and then 8 marks just by doing that particular process. Right, and part C, OB bisects angle ABC, find angle OAC. So OB, where's OB? OB bisects angle ABC. ABC. Aha, okay. So it bisects it. Right. So it splits up into two. I guess we have to work out this smaller angle, I'm guessing. Angle OAC. OAC. We need to work out the angle at the top here. Okay, interesting. And then we're told this bisects the angle here. Okay, so slightly different to what's normally expected. I think what I do here, bisects means split it into two equal parts, so this has to be 23 as well. It's the first thing that comes to mind. And then I think I would just use the idea of a four-sided shape adding to 360. Now, what do I mean by the four-sided shape? We actually have an arrowhead shape here, so let me draw this out a bit separately so we can see this. So we've got here, here. This is what's called an arrowhead, but it's still a four-sided shape, where this is 134 degrees. We now know this is 23. We worked out this at 67, and we're looking for the angle at the top here, so this is the question mark. Notice we can just work out the angle in the middle here, because we have angles around a point make 360. So if we just do 360 minus 134. Again, you can use a calculator for any of this, of course. You don't have to do it old school like I'm doing here. That gives us then 226, double checking, yes, I'm happy with that. 226, and then angles in a quadrilateral add up to 360. So if I just add together 226, 67, and 23, and add those together, get 6, 1, 8, 10, 1, 316, and then to work out missing angle, I just do 360 minus 316. And that's going to get to my answer of 44 degrees if I take that away. I'm not sure if that's the way the mark scheme would like to do it, but I think that seems pretty logical. Again, I'd include that working I've just done here under that particular section. But just using the idea of an arrowhead is a quadrilateral, like any quadrilateral, adds up to 360. Notice all that hard work of working out all the angles has really benefited me when doing this question. One thing to realize is this word bisex. So something I didn't really highlight too much. As soon as you see bisex, that just means split into two equal angles. Yeah? So split to two equal angles. Okay, so that's just an important word to be aware of. Okay, you can check the mark scheme. So this is exactly where I picked up all my marks. Do take that paper 4 strategy into account with these extended questions. You can see this is how many marks in total, 6, 7, 12 marks. I would more or less always approach it in this kind of form. Work out the angles you can and then see if that fits into what you need to do. Alright, and moving on to another short answer question. So O is the centre of the circle, and then find the value of x and find the value of y. Okay, so the first thing that comes to mind is, again, we've got the centre of the circle here. And then if I just extend, like I've done before, both ways, like so, there we are. And then see if there's an extra angle it's sharing. So it is in this case, because you can extend this way and extend this way. So you've got an angle at the circumference, you've got an angle at the centre. So remember, the angle at the circumference is half the angle at the centre. So to work out x, we just need to do 140 divided by 2, and that's equal to 70. And then don't fall for the trick here. Remember, at the moment, we don't have a cyclic quad. It seems that the Cambridge course does like to try and test this knowledge. So this is one of the benefits of watching a video like this with lots of different Cambridge questions. You can see what kind of thing they're looking for. And notice this is not a cyclic quad because O is not at the centre. So I do the same trick as before. I'm going to draw a dotted line to make my cyclic quad. I always like this method. This angle is the same as this angle here, x, which is 70. And so to work out y, we do 180 minus 70. And that's equal to 110 degrees. So we just pop that in like so. So watch out for that little trick. It seems to be quite a common thing on these short answer questions. Okay, and on to another big extended question here. So question 8. So A, B, C, D lie on the circle, centre 0. D, E, F is a tangent to the circle. At D, that's going to be important for that question A, that we've already seen that kind of question. A, O, C, F, so A, O, C, F. Okay, that's a whole straight line. And B, C, E are also straight lines. Okay, that could be important with angles on a straight line equal to 180. So again, already got that in my head before I've even started the question. Complete the statement. Angle ODE is equal to 90. So this is a right angle here. And the same reason as before. So a tangent and a radius, or diameter of course, meet at 90 degrees. Okie doke, perfect. And now we need to work out the angle AOD, ODC. I assume there's more angles need to work out. Lots of angles to work out. Right, so I'm going to approach this in the same way I've approached previous questions, work out as many angles as I can. First thing, this angle here, angles on a straight line, add up to 180 degrees. So this is going to be equal to 60. It's the first one that comes to mind. We've got a right angle here. Aha, we've got an isosceles triangle. So actually got a couple here. So notice this is a radius, and this here OA is also a radius, And in fact, OC is also a radius. So all these lengths I've just put in with these lines are all the same. Now, the way we can use this is we have isosceles triangles. We haven't seen too much of this in the video so far, but this is something you should always watch out for. If you have a center of a circle and some radii coming outwards, then you should always be looking for isosceles triangles. That means if this is 36, then the angle down below is also going to be equal to 36 degrees as well. And because angles in a triangle add up to 180, we can do 36 plus 36 is 72, and then do 180 minus 72. And that's going to be equal to 108 degrees. So this angle here is 108 degrees. Angles on a straight line, I think we mentioned this in the start of the question, add up to 180. So this angle here needs to be equal to 72 degrees. 180 minus 108. If that's true, we've then got two angles here that we can work out because we have another isosceles triangle. Okay, so let's do that. So that's going to be 180 minus 72 is 108 already, and then we do 108 divided by 2. That gives me 54 degrees. It's one of these little problem-solving questions where you just pop in all the angles that you know. So this is 54 degrees, this is 54 degrees. This is 54, then we can work out this one because this is a right angle. So this angle here, that's going to be 90 minus 54. Don't do anything silly now, Mr. Gower. So 36 degrees. Yep, double checking, that does add up to 90. So that's 36 degrees. No, that's 36. I'm probably going a bit overkill here, but this is quite fun, so I'm going to carry on. Angles in a triangle, so we've got 60 plus 36 is 96, so we get 180 minus 96. It's going to be 84, I think. Yep, so that angle there is 84 degrees. We can also work out the angle at the top here because we have a cyclic quad. Now you're probably thinking, where's this cyclic quad? Oh, is this 90 as well? 54 plus 36 is 90, therefore this angle must be 90 as well. Okay, doesn't look like 90, but we're just using cyclic quads here, using this and this opposite equal to 180. Right, anyway, let's see what we've worked out. So angle AOD, so AOD, yep, that's 108. Let's pop that in. Angle ODC, ODC, that's 54, yep, we did that one. Very satisfying, this process. ABC, ABC is equal to 90. Oh, so we did do the angle at the top here. ABC is equal to 90. It's one of the ones we did right at the end, but that is equal to 90. Angle CFD. Ah, this one right over here. We did not do this one right over here. This is true. Okay, so yep, this is one we missed out, but that's absolutely fine. We've got lots of information in order to do this. So we need to work out this angle where we've got 54, 84, and this all in a straight line. So we do 84 plus 54. That's equal to 138, I think. Double check. No, I really don't like using the calculator. And you do 180 minus it because it's on a straight line. That's equal to 42 degrees. So I think this angle is 42 degrees. This might be the long way of doing it, and the angle's in a triangle, so we do 180 minus 162, and that's equal to 18 degrees. So even though we didn't work out that angle directly straight away, there's probably easier ways to work that out as well. We can still just use everything that we've done so far. So this angle here is 80 degrees. So let's pop that in. I think I did go a bit overkill on this question. And then angle CAB is the one angle I didn't actually work out. Oh, that's annoying. That is quite annoying. CAB. So this is the angle over here. Right. So this is 90. I wonder if I can work out this angle easily. Vertically opposite, does that work? 42. Yes, it does, I think. So this angle here, because it's a straight line, this is what we're exploiting here. So this black angle here, 42, means this angle is also 42. For exactly that reason. And then angles in a triangle add up to 180. So then we do 180 minus 132. And that's equal to 48 degrees. The one angle I didn't work out, and there we are. But again, even if you don't work these things out directly, the great thing about this process is you've probably worked out enough of the angles to be able to work that out reasonably quickly afterwards as well. In fact, just looking back at this question, I should have realized ABC was 90 because we have a diameter here, and then angle that hits from the diameter onto the circumference is always 90 degrees as well. So we could have worked that out directly using that rule that we haven't really looked at so far as well. The thing about these questions is enjoy them, really do enjoy them, and just work out as many angles as you can, and that will really set you up very, very nicely for the following questions. Okay, so you can check your answers here. So all the answers are there and where we actually got those from. Unfortunately, this wasn't an extended question as I would have liked, in order to really benefit all that working I did to get all the marks. Right, I hope you enjoyed this video. If you want more practice on circle theorems, you'll see more of this in the PowerPoint linked to what we've seen already. So lots of different style of questions, like so. So feel free to go through these. I've gone through as many as I can within the amount of time that I have. If you want more on this, I can always make a part 2 on this as well, going through the questions you see in front of you. And if you haven't checked out the trigonometry section, which we did a part on the cosine rule, now I do suggest you check out the video right in front of you, because that goes through how did I know that formula so quickly. Well, I did that in my previous video.